You know, every single time you click on an online ad, you're kicking off this fascinating high-speed engineering challenge. So today, we're going to pull back the curtain and actually design the system that handles all of that, an Ad Click Aggregator. We'll take it from a really simple sketch all the way to a bulletproof industrial-strength system. So, what is this thing really? Well, at its heart, an Ad Click Aggregator is the engine that answers one critical question for advertisers. Hey, is my ad campaign actually working? It's the system that turns your simple click into super valuable data.
All right, here's the journey we're about to take. First, we're going to define the challenge. Then, we'll build a really simple first draft, and we'll see why it has a critical flaw. From there, we'll upgrade it for some serious speed, fortify it against failure, and finally, add one last layer of defense to outsmart all those pesky bots. Let's get started.
Okay, first things first. Before we write a single line of code, before we draw a single box on a whiteboard, we have to understand the rules of the game. What exactly are the core requirements for our system?
Functionally, our system really has two main jobs. Job number one, when you click an ad for, a new pair of sneakers, you have to end up on the sneaker website. Simple enough, right? Job number two, the advertiser needs to see how many clicks their ad got, and they need to see it right down to the minute. We also have to be really clear about what we're not building, like the system that decides which ad to show you in the first place. That's a whole different beast.
So this all sounds pretty straightforward. But, the real challenge in system design isn't just about the what, it's always about the how many. So what kind of scale are we actually dealing with here?
10,000 clicks every single second. I mean, think about that. That's over 800 million clicks a day. This is the kind of scale that completely transforms what seems like a simple task into a massive, massive engineering puzzle.
And because of that scale, our system has to be way more than just functional. It has to be wicked fast. When an advertiser checks their dashboard, that report has to load in under a second. The data needs to be fresh, no more than a minute old. It's got to be rock solid because every single lost click is lost money. And finally, it has to be smart enough to know that if a bot clicks an ad 100 times, that only counts as one.
Okay, let's dive into this. Every great design starts with a simple sketch, right? So we're going to map out the most logical, the most straightforward solution first. And on the surface, it's going to look totally correct. But trust me, it's hiding a critical, performance-killing flaw. The flow seems pretty simple. A user clicks, we log it. An advertiser asks for a report. We run a query to count all the logs. It's a straight shot from click to query. I mean, what could possibly go wrong? Well, the devil, as they say, is in the details, and in this case, it's the database. Our choice here creates this fundamental conflict. I mean, how can you possibly handle thousands of incoming writes every second while also performing these massive, complex reads for analytics, all at the same time? And this right here really illustrates that core conflict. See, databases that are optimized for writing data are fantastic. They can handle our 10,000 clicks per second, no problem. But the moment you ask them to turn around and read and count millions of rows for a report, they just grind to a halt. This approach would take forever, completely failing our under 1 second query requirement. It's just not going to work.
So clearly, our first draft is a non-starter. It's just way, way too slow. We need a fundamental upgrade to get the kind of real-time speed that advertisers are going to demand.
The key insight here is something called pre-aggregation. The idea is, instead of counting millions of raw clicks every single time an advertiser asks for a report, what if we did the math ahead of time as the clicks are coming in? So one way to do this is with batch processing. Imagine this. Every 5 minutes, a powerful tool like Spark just wakes up, grabs all the new raw clicks, counts them all up, and then puts this nice tidy summary into a separate database that's built for reading. Now, when an advertiser asks for a report, the queries are super fast because they're just reading the pre-calculated totals.
But there's a catch, right? If an advertiser launches a brand new campaign, they have to wait 5 whole minutes just to see if anybody is clicking. And in the crazy fast-paced world of digital ads, where thousands of dollars can be spent in minutes, 5 minutes is an eternity. The data is just too stale. And this brings us to the modern solution, stream processing. Forget waiting for some batch to run. Think of this more like a real-time assembly line. Each click event is a part that gets processed and counted the very moment it arrives on the conveyor belt. This table really shows the fundamental shift we're making. We're moving from a system that reports on what happened in the past to one that shows you what's happening right now. With stream processing tools like Flink and Kinesis, we can shrink that data latency from minutes down to just a few seconds. That's a game changer.
Okay, so our system is now incredibly fast. But speed isn't everything. Is it reliable? Can it survive a server crash? And what happens if, say, a huge celebrity tweets about our product and the ad goes completely viral? It's time to make this system bulletproof. Now, this is a really critical question. In a system where clicks literally equal money, we absolutely cannot afford to lose a single one. A tiny glitch or a bad code deployment could cause inaccuracies, and that is just not acceptable. So, how do we guarantee 100% accuracy? The answer is actually this beautiful hybrid approach called periodic reconciliation. We're going to combine the lightning speed of our real-time stream with the absolute, undeniable accuracy of a batch job. We really get the best of both worlds.
So here's how it works. Our stream gives us those fast, nearly perfect numbers all day long. But in the background, we're also saving every single raw click to some cheap, durable storage. Then, once a day, a big batch job comes along and recounts everything from scratch to get the perfect ground truth. And it automatically corrects any tiny errors the real-time system might have made. Speed and perfect accuracy, guaranteed.
Now, what about that celebrity problem? If an ad goes viral, all its clicks might get routed to the same processing lane or shard and create a huge traffic jam. The solution is really clever. For that one super hot ad, we temporarily add a random suffix to its ID. This basically tricks the system's traffic cop into sending those clicks down a bunch of different lanes, which spreads the load and keeps everything flowing smoothly.
So our system is fast, it's accurate, and it's scalable. But we have one last enemy to defeat: fraud. How do we stop these malicious bots from just repeatedly clicking an ad to inflate its numbers and waste an advertiser's money?
This is the problem in its simplest form. A bot can just send thousands of clicks per second for the exact same ad impression. We need a way to see this entire flood of requests and just count it as one single legitimate interaction.
The technical term for what we need here is idempotency. Yeah, it's a fancy word, but it's for a really simple idea. No matter how many times you send the same request, the system state only changes once. 100 clicks have the exact same effect as just one click.
This turns into this fascinating cat and mouse game. So our first move is to give every ad a unique impression ID, and we only count each ID one time. But then the bot makes its counter move. It's smart. It just starts inventing fake IDs. So we have to make our final move. Our server uses a secret key to attach a unique, unbreakable digital signature to every real impression ID. Now, before we count any click, we check that signature. If it's invalid or it's missing, we know it's a fake and we just throw it out. Checkmate.
And there you have it. We have systematically built this design up layer by layer. We started with a really simple, flawed idea, and we evolved it into a system that's scalable, it's real-time, it's incredibly accurate, and it's secure against fraud.
You know, this journey actually mirrors the way an engineer's thinking matures over their career. A mid-level engineer might get you to that batch processing solution. A senior engineer will probably introduce real-time streaming, but it takes a staff-level engineer to add those extra layers of reconciliation and security, thinking really deeply about all the nuanced trade-offs and all the little edge cases.
So, the next time you click an ad, you'll know about the incredible engineering journey that tiny little action kicks off. And it leaves me with one final question for you. What's something you use every single day that seems totally simple on the surface, but you know is hiding its own world of fascinating complexity? Thanks for tuning in.